And strategies. Automation, digitization, miniaturization, and demands for greater traceability and reliability are all driving inspection equipment to their limits. This panel will discuss how inspection systems will cope with these challenges in the future and what performance metrics we can expect. I'm joined by two very distinguished panelists, colleagues and friends actually. To my right we have Dave Bennet from MIRTEC Corporation. Welcome, Dave.
Thank you, Trevor.
And to my left we have Keith Bryant from Yxlon. Welcome.
Good morning.
Okay, good to see you again. So I'm going to get straight in, guys. I mean, the first thing I'm going to ask is, what are the leading inspection challenges facing companies today?
Okay, I think we, as far as technology is going, I think we're pretty much knocking the ball out of the park now. AOI's come on in leaps and bounds, and if customers can't find the faults with the equipment they've got now, then sadly they've got the wrong equipment.
When you go to a factory, I mean, what are the key things they're saying that they're finding or they're having issues with?
It's not, I don't think it's so much a standardised thing with issues, Trevor. I mean, lifted leads was always a big thing with 2D. Good 3D's taking care of that. And, BGAs, I don't know if my BGA's down properly. Now with 3D measurement, we capture that as well.
Right.
So AOI can still do what it's designed to do, which is to find these faults. And now we can find virtually everything. I would really struggle to think the last time somebody showed me a product and said, how do I inspect this? And we didn't have an answer for it. The biggest questions I keep getting asked about is, can it communicate? Can it tell me? Can it help my process? That's really, and if you think 10 years ago, even more, 5 years ago, that didn't exist.
Well, that machine-to-machine communication is what we've been talking about all week.
Yeah.
And that is definitely at the centre of everybody's mind. Right?
Yes, yeah, I agree.
I agree. Important.
But I don't think there's any one thing that's caused us a problem. There's things coming that we know about, like bottom terminated products and all these sort of things. But again, there are ways and means that the inspection companies, not only MIRTEC, I'm sure, but the better ones, are looking at providing solutions to their customers.
Right.
So nothing really scaring us at the moment.
Nothing scaring you. Okay, so there's nothing out there that you can't handle. That's interesting. What's the situation on the X-ray front? I mean, you're looking for different things. Dave is identifying the issues. You're actually going deeper into the problem.
Yeah, it can be. I mean, and going deeper into the problem is one of the problems, if you like.
Right.
Inline XRay has struggled for a while with, let's call them false calls.
Yeah.
And now they're struggling also with the takt time of the production line. Because, the speed of your line is the speed of your slowest machine within the line.
Correct.
And in a lot of cases it becomes the inline X-ray machine. So people start to cut corners and try and speed up the process and end up not doing a good inspection and end up with more problems with false calls than they had before.
Right.
But with regards to offline inspection, even the very small components don't cause that much stress to the higher end machines, because they're looking at semiconductor components where you're looking at faults that are a couple of microns, where you have very little difference in background resolution.
Right.
So the stuff in circuit board assembly isn't really that challenging.
Right.
So, like Dave, we're, thankfully, on the ball, and if not ahead of the game, but at least keeping up with it.
Keeping up with it. There you go. Oh, well, that was an interesting response. So, how is the industry coping with a lot of the bottom terminated components coming into the market?
We're not seeing that many yet, but we know they're coming, of course. And again, we need to have a solution available before our customers need it, not afterwards. Too late then. MIRTEC, because of our camera and lens configuration, which is totally different to anybody else in the industry, because obviously we make our own optics, which is pretty much well known now. We're measuring at 2 micron accuracy, and in fact, in the semiconductor division within MIRTEC, we're doing things that are absolutely unbelievable. It's not my industry, but I was in Korea recently, and the sort of wafer bump analysis and some of the microelectronic stuff they're doing is staggering, absolutely staggering. And the power is that the cameras again, it always comes back to, if you think about it, an optical inspection company, the most important thing is optics. What you can see, and if you can see it better than everybody else, then you've got a hell of a chance of giving them a really good result. So with bottom terminated devices, the key thing is, we can see that they're in position, do all the normal things that we would do. It's almost like looking at a BGA as far as we're concerned. The thing we're going to see is positional, then we're going to see tilt, and we're going to see, because of the 2 micron measurement, we're going to be able to pick this sort of thing up. And if someone says, okay, it's failed, the next thing, of course, is the same as a BGA. If you want to know why, if there's something wrong underneath the component,
it's a complementarity issue or something like that.
You're going to have to again turn around and say to an X-ray company, can you see what caused it? We'll find it. And in production, of course, that's the most important thing.
You could see the complementarity. You could see.
Oh yeah, we can measure that. Yeah, we're doing that now with BGAs and flip chips and things. That's quite easy. And this is just a different shaped version of that as far as AOI looks at it. We've got to catch it for our customers if it doesn't look right, if it's not measured right. And then it's up to the X-ray people if they want to go further diagnosis.
It's up to the X-ray people, just like BGAs.
Yes, exactly right. And that's where we sit. And David was very tactful and didn't mention it, but there's a cooperation between MIRTEC and Yxlon using something called Smart Loop, which actually does the, let's call it the finite inspection as to if there's a coplanarity issue, is it good or is it bad? Does it have joints or does it have open circuits? And really that's the necessary thing to close the loop.
No, Smart Loop does all the, lets the AOI do all the grunt work of the overall inspection, identify the areas of real concern, and then overlap the X-ray to go to the area of concern. So
basically you load the machine into the X-ray system, you scan the barcode, it pulls all the data from the other 3D AOI system, and it puts the operator in exactly the spot that it needs to look at. To inspect it, and then the manual part of the system takes over, so you can interrogate the joints, you can look from an angle, you can zoom in, you can zoom out, you can play with the contrast and the filters and get a finite decision as to whether this, let's call it false call to an extent, because you don't know whether it's good or whether it's bad. It lets you know exactly what's wrong with it. If you've inspected, let's say, 20 QFNs that were all slightly warped, but they all had good joints, now you can go back into Dave's system, you can open your process window a little bit, and you continually have process improvement in real time as you go along. So it's all about staying within the window, not finding faults.
It's an excellent system for sure. Dave, coming back to you, as AOI, as boards get bigger and more densely populated, more miniaturization and everything else, is tack time going to become a problem?
Yes, it is for a lot of AOI companies. Again, I'm sort of banging the drum about the fact that we design and manufacture our own cameras. We're ahead of the game because, you can imagine with a 25 megapixel camera compared to a 4 megapixel camera, the field of view is incredible, which means obviously it's going to be really fast. Currently, we only use that camera configuration with a very small 7 micron lens. So it's not about speed at the moment, we're using it for detail, and that again translates across to our LED manufacturing inspection division and also our semiconductor division. They tend to use that camera. In SMT, we're too fast. I mean, it's so fast, it's blistering. So we tend to have a 15 megapixel main camera and a 15 megapixel set of array cameras, angled cameras, and they keep up with the line fast enough. Because again, we start with a really big field of view. We then have a choice of different lenses, and those lenses will allow the customer to go faster or take a bit of time and look closer, depending on what his speeds need. We are just launching an 18 megapixel, and the 18 megapixel has got the 18 megapixel side cameras to go with the main top camera. Again, that's going to give us a huge field of view to start with in comparison to anyone else.
It's going to obviously generate a lot more data.
We will squash then the field of view again because we're going to use nice tight lenses on it, but because we start in a bigger position, we end up with a bigger field of view than anyone else, which means we're faster, but at the same time the detail is incredible. So we have this capability of mix and matching our range of cameras, and there'll be more. I mean, I know there's lots of other things coming with the camera division, so MIRTEC will always be giving a solution on the optics. And for us, as far as the beat speed goes, we've always got the opportunity of opening up to the more typical lenses that other AOI companies use. They're up in sort of 20, 25 micron lenses.
Right.
We're down sort of 9 and 7 and 10, and so we're right down the other end because we're going for detail.
Right.
And that really is our segment of the market. If it's got to be seen, and it's really got to be seen, we'll see it.
Okay. Tack time, it's more a problem for X-ray, I would think, than for AOI, because you're a much slower process.
For inline X-ray, yes. Because not only is it a slower process, but there are more and more things that you need to check. Now, when inline X-ray started in 1980, let's say mid-1980s, you had through-hole components. Really, you were just looking for fill in the holes, and you were looking for, is the component there or not?
Right.
Yeah. But now you have a way higher packing density. You have more complex components. You have more things that you need to make decisions on, like BGA balls, micro BGAs, and then QFNs, where you have to, you've got to find exactly where the joint interface is to know if there's an interface. We all know that printed circuit boards are never exactly the same height. They're never exactly the same thickness.
Right.
And after they've been processed through reflow, they're never flat. So inline AOI can cope with this by doing relative measurements to, like measure beside the component, then measure the component. But obviously X-ray, you can't do this because you're looking through everything. So it just becomes more, for inline there are more and more challenges, and there's less and less chance of speeding up the process because you need better and better results.
Right. Both AOI and X-ray markets are becoming pretty saturated. So what do you think will differentiate the stronger brands in the future?
Well, for us it's good news because it's all about complexity. The harder and the more complex and the more miniaturized the product being built is, the more we stand out. So we actually like the way it's going.
Right.
Easy, simple boards, easy, simple machines. Very complicated boards, very clever machines. And we've, as a company, always gone for the very clever machine side. People turn around often and say, who's the number one and whatever, and I say, well, if you look at an analogy with a car, if you had a choice between a Seat and a Jaguar, you pick a Jaguar, but Seat sells sort of 20 to 1 in comparison. Right. So which is the number one?
Right.
So those sort of questions really don't mean anything. If you ask technology-wise, who can do things, I know MIRTEC can do many things that are going to be completely out of the realm of our competition. Mainly down to the fact that if you don't control your optics, as an optical inspection company, you start with nothing. Right. You're just relying on what's on a shelf.
Right. Yeah, I think it was a smart thing you did, buying your own camera company, for sure. That really did give you give you an edge.
We didn't actually buy it, Trevor. We actually employed the people in-house. We brought them in.
Oh, I see.
Yeah, we brought them in and developed it because we could see that the industry was going to need a lot more via optics than we could get from any supplier.
Right.
So we had to, it was a conscious decision by our CEO, cleverest decision I think he's ever made, and it's what sets us apart.
Right. Keith, you've got to keep at the edge of technology, basically. Yep. Keep reinventing yourself.
I don't know about reinventing yourself, but technology will always be a differentiator. There'll always be something that's going to be lower cost. But cost, as we all know, is only part of the equation.
Right.
It's about service, it's about support, it's about reliability, and all the rest of the things. And when you're spending a lot of money on a piece of equipment, it goes back to the old story of nobody ever got fired for buying IBM.
Right.
Yeah. Yes, there are a lot of X-ray companies coming into the market. There's a place for all of them because more and more companies who haven't even had X-ray up to today are finding that their customers are driving them to do it. And we went through a phase where it was almost like a tick box. Right. Yes, I've got an X-ray machine, tick. But unfortunately for those guys now, the customers are becoming a little bit more intelligent and they're understanding exactly what X-ray does.
Right.
And they're now starting to specify the amount of voiding that they'll accept and a whole load of other things. And this then drives them to have not only better equipment, but equipment that's more reliable and equipment that can produce the same result from today to tomorrow to next week. Right.
No, I believe that. Let's move on to the next question here, which is, in an industry moving towards greater machine-to-machine collaboration, is there a long-term future for AOI as an image-driven system, or will it be replaced with a 2D or 3D metrology system?
It's an interesting question, Trevor. The thing is, with probably 2/3 of the market maybe even more than 2/3 of the market, still running 2D AOI. If you had the metrology machine today, and it would have to be very fast, it would have to keep up with the takt times, and be able to do more than the 3D AOI machines can do. So it's not really there yet, or else it would be here. Yeah, but who's buying them? I mean, that's
I don't know buying them.
It's speed. I mean, that's the trouble.
Right.
I mean, you mentioned earlier about takt times and things. They're a little slow. The industry, as we're sitting at the moment, is transferring gradually from 2D to 3D. Whether it will go in the future from 3D AOI to metrology, I'm not sure. I don't know. If it does, there'll be a good reason for it. And if that reason exists, there'll be a MIRTEC one. I can guarantee that. So, and it'll be a good one.
It's an interesting question because within X-ray we're actually seeing a drive towards the need for metrology.
Right.
Historically, we've always used the phrase that the real name of an X-ray machine is an X-ray microscope, and it's not a metrology. It's not a measurement system. It is a microscope. But more and more companies now are driving, at least in the failure analysis and the laboratory type side, towards wanting a metrology-based system.
Interesting.
And that's driving the higher-end X-ray machines to have better lead screws, better stepper motors, more accurate, more repeatability things, and also it's increasing the amount of people who are looking at CT. The pure CT systems can be metrology based,
right?
Whereas the good old 2D offline X-ray, it's very, very hard to get accurate, repeatable measurements of them.
Right.
So metrology is something that's driving us.
Right. So you're getting fairly decent metrology data back from on the 3D basis, but not on the 2D. Is that what you're saying?
The 2D is difficult because you're working with a cone beam.
Right.
And where you have a cone beam, obviously you have diffraction, you have differences, you have basically a curve.
Right.
So it's very hard to measure something when your image is coming out effectively as a curve. So it's much better to have let's call them the systems that are coming down from the NDT, which are now able to see sub-micron technology.
Right.
And those systems are what we're calling crossover systems now. And they're starting to appear in the failure analysis labs of the bigger companies.
Right.
And they're actually using the metrology within their system. So now there's talk of having a software where you can take the design and you can compare the actual measurements that you get on a board, or even a complete assembly, to the design measurements that should be. So you have the design measurements and the tolerances, and basically you can now do a comparison between.
So you can do a comparison.
You're back to the golden board,
right?
But you're talking 3D, fully dimensioned golden board against what you have as a CT image.
Right.
I mean, I don't think anyone is there yet, but that's going to be a game changer.
It could be. I mean, if you can crunch the numbers fast enough on it, it certainly would be. Yeah. Okay. Dave, do you think there's going to be further integration of AOI into printers and place equipment?
Possibly. I mean, there's a way to do it. One of the major things is miniaturization of the actual sensors. The cameras were quite big. I mean, especially when you're talking high-speed cameras, and of course we all know that the queen of the placement line, the production line is the pick and place machine.
Right.
And the pick and place machines forever have been banging on about how accurate and how fast they can go, which makes sense. Now, to put in a camera inside that system,
wicked in about.
I mean, you've got it. It's banging around at high speed. You're looking to do. I mean, we're doing two micron accuracy inspection, and we use a very solid platform to do that with a superb robot system, both the linear and the high precision servo that we use, and. We've got a 2 micron repeatability on the robot, 5 micron on the precision servo system. To put that inside an AOI machine, inside a pick and place machine or a screen printer, is it possible? Yeah, of course it's possible.
Right.
But there's also the dilemma, Trevor, of saying, I'm company X, here's my placement machine, it's the best and the fastest in the world, and I've built in this test stuff to prove it. Are you going to believe it? It's come from the same source. Whereas if you've got an independent testing system from any company afterwards saying, yes, it's doing everything you're expecting it to do, I think that's far more valid and far more acceptable to the customer.
Okay. I'm going to stick with you for a minute on the second question. That is that we currently have a closed loop systems between printers and SPI, SPI and or AOI and pick and place.
Sure.
What role do you think AI will play in the future? Because people are talking about this. At the moment, it's a closed loop correction system, but is it going to become self-learning?
That would be fantastic. I mean, to have a situation where the data that was being identified as starting to slide out of control could automatically be reconnected or calibrated and get the machine back into the performance position that it was meant to be in. That is obviously the perfect dream. I mean, one thing, you don't need human beings. All they're there for is to load the components and whatever, and even that would probably end up going into robotics.
Right.
So there's lots of exciting ways that our industry could go, and if we could leap forward in the future and look at all the clever technologies that we can find in a show like this and see them implemented at their best, I think we'd be quite staggered what our industry could be. But to give you a slightly more focused thing, I hope so. I hope so. Yes,
That's
I do.
interesting
I
because-
do.
Yeah, because, you know,
I mean, the thing is,
Don't-
intelligence is intelligence wherever it comes from.
right, but if you let machines become self-learning, where does that stop? You know,
Well, again, don't
Dr.
forget-
Stephen Hawking,
Yeah.
you know, he said that AI is potentially mankind's, you know, biggest threat.
As long as I can wait a few years, I'll be okay. But I mean, to be honest with you, I think if you look at intelligence is one thing. It's the actual usage, and if the usage of the intelligence is done wisely, then you can automate a lot of things. Where at the moment, I mean, one of the craziest things in our industry is when you see statistical process control meetings that are like a week or two after the
That's
event.
crazy, yeah.
It's the most ridiculous thing ever. Yet our industry's still full of it.
Yeah.
You know, there have been tools for dynamic process control, so you know what's happening now, the trend now
Right.
in this industry for the best part of 20 years.
Right.
Now we're all getting excited about Industry 4.0 and everyone's saying, oh, what a great idea, why don't we do this? And you think, it's been here forever.
Yeah, there's a lot of ignorance out there. What do you think about artificial intelligence in the systems?
I think, unlike Dave, we're a long way from it.
Yeah.
And I think ultimately AI in theory is a wonderful concept, but you still wonder, you know, how much of the knowledge that's, well, okay, we're at an exhibition, it's full of engineers.
Right.
Those engineers have years and years and years of experience and knowledge. To get that into an AOI system that's then going to build it up, I think we're away from that yet. But
I think it's a good
any good system is a good system.
Right, I think it's a good idea that maybe an AI system could detect something that it thinks is going to have out of spec.
Yep.
But it should always maybe bring it back for human verification before it's implemented. Because otherwise, if you let the robot or the machine go willy-nilly, changing specs, which might have other effects up the line, etc., you know, it's dangerous.
Back in the day, we were feeding back from an AOI machine to a different company's pick and place machine, one of the biggest names in the market, and we were adjusting it as we were getting drift data, etc.
Yeah.
And the pick and place company went nuts. Basically, that there's this AOI machine telling it what to do, continuously changing its machine.
Right.
And in the end, what we had to revert to was that the AOI machine would send back the information that it had found with suggestions on a Pareto of, you know, we believe it could be this or this or this. And it was even basic things like a bit of paste to go up a nozzle, but it was all on a Pareto, you know,
Right,
and that's how it was worked. And that was far more acceptable. The other thing, of course, is again, because of this cross-company interfacing, that's going to be, I believe, the biggest dilemma. If you said to me today, Industry 4.0, is it going to work? I'd say it does work. It's there. The problem's going to be the collaboration between different SPI company, different AOI company, couple of different placement companies, reflow company, maybe one or two different screen printer companies or other technologies. We've always been our own little empires.
Right.
And now suddenly we're all going to be best mates. And I'm very open to this because, like I said, I did it in the past. But I have a vision. The only way it can work is the black box. You know, where you send your information into a black box, and an integration company deals with it.
Yeah.
And we don't have to get involved with each other.
Yeah. No, I think you're right. Let me turn to you about X-ray. There's an X-ray question here. Obviously, X-ray has the ability to see under components and devices in the places that AOI can't see, but it's a very slow technology. What can we do to speed it up in the future?
Interesting question, especially as we're going to get more and more bottom terminated devices where you can only effectively do a real inspection in X-ray. And the secret is, and I hope Dave agrees with me, nobody wants to inspect something that's good.
Right.
You only want to inspect something that may be bad and decide whether it's acceptable or not.
So isolate it. In other words, back to your smart loop thing.
Yes.
I isolate the
you have a production system that's, let's say, 3D SPI. It's 2D SPI after placement, and it's good 3D AOI with good Z height Moire measurement at the end of the line. And anything which looks suspect up there can then be put in the X-ray machine. But if the board's good, you don't want to look at it. It goes through the edge.
Makes no point to be inspecting areas that are already.
But you know, you talk to some people and they're still hung up with this. We need 100% X-ray inspection of all of our components. You know, and that says basically you believe that the person who's building this has no control over their process. You know, and if you believe that, you shouldn't be, even if it's your own company, you shouldn't be working with them. If you believe that, yes, occasionally you're going to have a component that's not sitting flat, occasionally you're going to have a VGA that's not down like it should be. You know, the days of missing balls disappeared a long time ago, and most people have got up cameras now on their pick and place machines. So, you know, everybody says, well, you need to X-ray every VGA because there might be a missing ball. Do you how? Because your pick and place machine's already done it.
Doing it,
So, you know, it's about checking the things that may be bad, and ideally bad, but still within your process window, so that you can keep everything running and everything that comes out the line is good. And for me, that's a better goal than artificial intelligence.
Makes a lot of sense. Okay, I'm going to skip to our last question because we're starting to run out of time, and basically I'm going to ask what you think the next big evolution is going to be in inspection technology. Where are we going?
I don't think there's going to be another big step. I think 3D was a massive step. I think the next step could be what we mentioned a little earlier, that there might be some more integration into metrology, maybe being developed within the 3D package. And you know, once you've got an AOI system which is already doing measurement, and you're now able to give it some extra measurement capabilities where required. Again, of course, optics will never change. As long as we're looking at something, optics will have to keep evolving and getting better. Smaller lenses, but starting with a larger field of view, incredibly accurate detail. I think a new sensor to come in with the impact that 3D brought into this industry. I don't think there's one of those on the horizon.
I tend to agree with you in the metrology thing, because I mean the rest of the line basically is all getting data driven and going towards that. And AOI can't hang out there and be the outlier. No. It's got to be in there, so it does have to go eventually to something.
I mean we've seen different technologies mixed before. We've seen X-ray, AOI to relatively limited success, I must say. You've seen the benefits of X-ray and AOI separately, where they're both much stronger. We've now seen the emergence of the metrology systems. Whether metrology and 3D AOI will work better, don't know. I mean, but it's one of these things where it sort of surprised me that as an industry we're so driven on catching the issues, and only now are we waking up to the fact of why are we making the issues.
Right.
That's the strange thing.
I mean, this whole idea that you have production meetings a week later to go over the SPC data and say this is how much scrap we produced last week is
and who should we blame?
It's ridiculous.
Yeah, it is.
Totally ridiculous. Okay, last word to you, Keith. What's coming next?
Well, for me, I think 100% yield in real life. That's going to be the next big step.
Okay.
And if we can get there, and that's really going to involve, as I say, online and at-line inspection machines talking to each other, feeding back in real time, and effectively the ability to keep your process within the window. And that may sound like a small thing, but when you look at everything that's going along, it is a huge thing. But at the end of the day, we control our process. We control our inspection technology. We control the materials that we use at the beginning. In theory, we should be able to retain 100% yield consistently.
I think it's achievable. I mean, I just don't know about the time frame, but I think it's certainly a good goal, and I think it is achievable. But I think you're right. Anyway, thank you for joining us today, Keith. Much appreciated. Same for you, Dave. And thank you, our audience, for joining us today. This is the last of our panel discussions for Tuesday. That's it, and we say goodbye from SMT Hybrid Packaging here in Nuremberg, Germany.